Good afternoon and welcome to the 12:30 session. I'm George Middendorf and I'm here with Vicki Rogers and Ken Klimo. Many of you just heard Ken, and what we're going to do is talk a little bit more about how to foster interdisciplinarity thinking through lessons that follow the 4DEE approach. And for those of you who saw Ken's earlier and Luana's earlier presentation, you're familiar with this slide. This is the 4DEE um, logo, and along with the fact that the four dimensions include core ecological concepts, ecology practices, human environment interactions, and cross-cutting themes. But what we're going to talk about today is how to set those dimensions into an interdisciplinary context. And we're going to go through and talk very, very briefly about three examples that illustrate how to do this. And Vicky's going to talk here about interdisciplinary thinking for just a moment, and then I'm going to come back and talk about an example. Then we'll go to Ken and then to Vicky.
Thank you. So just to highlight, I think it's probably fairly evident for most at this point, but the importance of interdisciplinary thinking, right? And sort of really what that means. I like this image here at the top, really showing sort of the difference between thinking about something through one specific lens, one intra-disciplinary focus, and then multidisciplinary, cross-disciplinary, and then what we're really aiming for here is towards the right end here, interdisciplinary or maybe even transdisciplinary. And there's been lots of calls for this out there in the world of education, especially in higher ed. You can see some of the news clippings here really calling for more of this and in higher education. I'm gonna go to the next slide. And specifically thinking about interdisciplinary thinking in ecology and how it fits in with the 4DEE framework, we've sort of identified two major pieces that help us do this, I think, really well, and we'll pull some of these into the examples we're about to go through. The first is ecosystem services. And you can see on the left-hand side here, the idea and the visual here put forth by Costanza that I think is a really effective call for interdisciplinary thinking in ecology, showing that human well-being really depends upon the really complex interactions of the natural, social, built, and human capital, right? It is not that natural capital directly feeds easily into human well-being, but there is a whole series of very complex interactions which call for many different disciplines that need to be integrated. And then also on the right-hand side, the other piece of this interdisciplinary thinking in ecology that comes up a lot is the socio-ecological systems frameworks, and thinking about that kind of the interactions of those. You can see here, this is Ostrom's framework connecting the ecosystems with the social, economic, and political settings, and really understanding the complex interactions and outcomes associated with those. And this is a really great way to start getting students to think about and incorporate systems thinking as well. Next slide.
So what I'd like to talk about just briefly this morning, I'm going to elaborate a little bit later afterwards in the next session. But what I'd like to talk about is the Crosstown Walk. That it's an exercise that I've been doing at Howard University for a number of years. And it reflects back onto the discussion earlier this morning about the human biome and the microbiome, and that the field can be in your home. Well, the field can also be in your city as well. And you can use and do ecological studies in the field. And I began the study back in the late 1990s when two satellite photographs came out. And you can see these in the upper left section. The one on the upper left was taken in 1973, and the one next to it was 1997, and it shows a decline in tree cover in the Baltimore, Washington, D.C. region. But when you zoom in on Washington, D.C., what you see is that an incredible decline of trees, and almost all of which occurred within the African-American neighborhoods. Howard University is located on that right-hand side of the diamond there. And what what we noticed was that when we walked from Howard University, which is in the middle here, I can't show you there, right there with that arrow. And when you walk across over to DuPont Circle on RST streets, you walk from an area that was in 1997, 2000, had very few trees into an area with large numbers of trees. And I developed a lab, and it turned out that Charlie Nylon at the University of Missouri was doing something very similar. And we wrote this up as a TIEE lab experiment for taking students out and doing ecological studies in an urban setting. And what I want to do is just briefly kind of go through this thing and tell you what you can do with this. And so I'll refer you to the web page for this. It's part of the ESA TIE Volume 3. So over the years, I've worked with a number of different graduate students, two of whom have actually done master's theses in using this approach. A number of undergraduate students, all of whom are listed here, who did honors theses, and I've used it in 4 different classes: my ecological and environmental graduate course, my ecology undergraduate, my environmental studies, my honors research, and my science and public policy. I guess that's 5 courses. And it's really adaptable to any of these and can be used in a number of other courses. And what I'm doing these days is I take the students out, we do the Crosstown walk, and when we get to DuPont, we turn around and we come back. And when we come back, the students are tasked. We just make observations on the way down. When we come back, the students are tasked with collecting data about something. And so they generally pick their own topic, and they work in groups, and they collect different data, and they put the data sets together and then do analyses. In recent years, we've started to look at the benefits of trees, and because of that difference between the trees in Howard University's eastern part of the transect and the DuPont Circle western part of the transect that you can see right here in this picture. But the benefits of trees are really quite incredible. They reduce pollution, they reduce the use of energy, they make the temperature quite different, they change the runoff patterns, the stormwater costs, and they change the air quality quite dramatically. In large part, the air quality in Washington, D.C. is determined by vehicular exhaust and traffic. The dust and debris and incomplete combustion lead to the formation of particulate matter, PM 2.5. This is pretty nasty stuff. The small particles that get into your lungs and cause asthma, dementia, and other major health issues. But the trees mitigate this, and they mitigate it by capturing the PM on the leaf surface, sometimes retaining it on the leaf surface, sometimes just slowing the speed of the wind that allows the PM 2.5 to drop to the ground. But they're very different differences. And the way we characterize these differences, and here on the right is over near Howard University, and you can note the absence of trees, and on the left is further west where you start to see a fair number of trees. And what we did with the students is go through and set up a grid here, going from Howard over to DuPont Circle and collecting information on particulate matter at each of those stations. And a partial summary of the report reveals that the particulate matter level is positively correlated with crosstown street traffic. It shows that the areas adjacent to major thoroughfares exhibited higher levels of particulate matter. The tree canopy data did not correlate with very well with the particulate matter. And we think that that's due to differences in the tree type, tree size, and perhaps in terms of the tree leaf morphology itself. But the real issue here is that the Black neighborhoods near Howard University have more traffic, fewer trees, and much higher levels of particulate matter. And what this whole process did, and I can elaborate on this for anybody who wants to talk about it, but what it does is it takes those 4 dimensions and it exposes students to core concepts in terms of vegetation, trees, et cetera. It talks about ecology practices, data collection, data analysis, et cetera. It looks at the human environment interactions in terms of looking at the impact of the different ecology and different environments in different human communities, and it brings together cross-cutting themes. And what it does ultimately is it provides the students with a framework that illustrates how they can use science to examine critical issues that affect their communities. And this in turn enables them to participate effectively in public decision-making, and it fosters their consideration in the use of science in the development of just and equitable public policy. It's been a tremendously exciting and useful approach, and it's one that I and Charlie have taken to numerous other cities, and in fact, many of you may have participated with us on one of the Crosstown walks that we do annually at the ESA meetings. And I'll stop here and shift to
me. Great, thank you. So I just wanted to mention that we're going to kind of go through our examples here sort of quickly, but please, we encourage you to put some questions into the question and answer little box, and because we will save time at the end. So before I jump into my example, I just wanted to sort of introduce myself because I think I'm sort of maybe in a unique or different place than maybe many ecologists. My name is Vicki Rogers. I'm at Babson College, and I've been there for 13 years now. And Babson College is a business school. It's in Massachusetts. And so all of our majors are business students. So it's kind of a really unique place to teach ecology. I myself am a purely trained ecologist. But I teach only business students, and I teach them ecology. So I may call it sort of ecological management, but they're getting an ecology class. But I teach it around this 4DEE framework so that students can, part of that real benefit is sort of the hook to get them interested and to have them realize the connections for them. And so I just wanted to share with you one example here that I just started this semester, actually, for a group project for my students. And so this is an interdisciplinary connection for connecting ecology to business and to the economy. So natural capital accounting is what this is framed around. This is really looking at ways to value ecosystems. And so you can see the image here, sort of the connection with businesses and other capitals and how they cause and are impacted by environmental impacts. And so I tell my students that this is something that is growing in business, and they get very, very excited when I tell them that, you know, I've heard EY talk about their natural capital accounting, and this is something that is really important to them. Next slide. And so taking the 4DEE approach, I've just pulled out a couple pieces here for how I designed this. You know, it really is focusing on the ecosystem level concepts for the core concepts. The ecological practices that I'm addressing here are sort of working collaborative. This is a group project, and then being able to communicate and apply their ecology in what is their final deliverable, which is a presentation. It is strongly centered around the human-environment interactions. So they need to understand the human dependence, environmental change, ethical dimensions, and the major cross-cutting theme that they're addressing here is sort of a systems perspective. There are a number of different interactions as well with the human-environment interaction, human dependence connected to understanding the ecosystem concepts, you know, systems connections to working collaboratively that are in this project. Next slide. So what I have students do is select one of the major regions that is currently undergoing intense deforestation, and you can see some of them highlighted here. And they need to investigate the major driver for deforestation in that area and focus in and select just one. You can see some of the ones that are listed here: soy, beef, oil palm, pulp plantation, and cocoa. Next slide. And so what I have students do is frame their thinking around roughly a 100-hectare plot, and then research the ecological and social impacts of deforestation to this area. and start to calculate and estimate the losses of ecosystem services and therefore the impacts and connections to community health. So in the class as a whole, we do a lot of systems thinking and connections of socio-ecological systems. And so I really want them to be able to highlight how ecosystem services would change with these shifts to a deforested area and how that would impact the local community. Students get really challenged by this, right? This is a difficult sort of open-ended complex problem, but I sort of walk them through coming up with justified estimations to be able to go through to find some of this information. They very much want to just kind of look it up and find the answer, and that's not out there. So I think it helps with their critical thinking in going through to do this as well. Next slide. And for this project, we've already sort of talked about natural capital accounting within the class. So you know, this is one of the slides that I use to introduce that and have them look and compare the net present value, which is something my business students know a lot about, of an intact mangrove compared to a shrimp farm. So converting an intact mangrove over to a shrimp farm, which is often what happens, you can see the complete change here in value. And if we actually, you know, took account for all of that, the decision to do this would be simple. You just wouldn't, right? And so this is sort of the way that I'm asking them to think about their forested piece of land. Next slide. So what they end up doing is going through and doing a research outline to pull all of this information. They then need to and get some feedback. I give them a number of sources. They have to find some of their own, but there's some great information through the economics of ecosystems and biodiversity, TEEB, the World Resources Institute, the Natural Capital Finance Alliance, and Natural Capital Coalition. And they put together a presentation, a group presentation, where they need to defend their choice for the land, whether it should be deforested and converted over to whatever their driver for deforestation is, or if it should be conserved. And they need to propose a plan, if they're conserving it, for how to offset the costs for not converting the land. So is that something like payment for ecosystem services? Is it an ecotourism plan? How would you be able to secure conservation funds? And discussing, they also need to include a discussion of some of the non-monetary value for parts of the ecosystem and some of the ethical problems with only valuing things through this approach. So I'll end there and turn over to Ken to talk about his example.
Okay, thank you very much. So what I want to do is just to give a short overview of a unit that I've developed. And again, this is part of, if you were part of the presentation that I gave earlier today, one of the things that I mentioned was about choosing low-hanging fruit. And so this was the low-hanging fruit for me. I teach a course in field botany every other year. And part of the course relates to plant identification, and then part relates to plant ecology. One of the things that I do on a consulting basis is that I go out and delineate wetlands for fun and profit. And so there's a lot of wetland ecology that I believe that my students need to know. And so as I looked at this unit on wetlands that I provide to students, it really lends itself to the 4DEE approach. And so I have a unit that I've put together. It's been reviewed by EcoEd Digital Library. I have some minor revisions to make on it. And then once the revisions are done, it'll be available through EcoEd to be able to download for free. And so the introduction then is where we talk about basic principles. We lead the students to online mapping, and then how do you go out in the field and do identification of wetlands in the field. All right, next slide, please. So as far as the purposes of the unit go, Again, I can read off the slide here, but to give students the opportunity to learn about wetland ecology, the classification of wetlands in various ways, their functions and values, which are, again, relate to the theme of what we're doing here on the theme is interdisciplinary thinking, and then also the legality of wetland preservation. So that would be the first thing. The second thing is that there are online mapping tools that are available for the general public to use to identify wetlands. And so we have students get into some of the online mapping tools to be able to know how to remotely identify wetlands. And then the third part is to provide students with an in-field exercise in which they learn the elements of wetland delineation in the field. And if you know about wetlands, you know that they're identified and delineated really according to three parameters. One being the plants, a second parameter being the soils, and then a third parameter being the hydrology or the pattern of water availability. And so we have students then be able to look at those things in the field and to see how the field indicators show whether an area is or is not a wetland. Next slide, please. So right here, this is just simply a graph or a figure rather that shows this area of this concept of wetland functions and values. And the idea is that wetlands are wonderful at interdisciplinary, getting students to think in an interdisciplinary way. Certainly from a function and value perspective, we know the wetlands clean up water. We know the wetlands provide erosion and flood control, very important in what we call flooding desynchronization. Wetlands also provide natural products, so they have commercial value. There's certain cultural values associated with wetlands, recreational values. They serve, as we're finding out in Louisiana, they serve as storm buffer zones, and then they provide wildlife habitat. And then if you're into education, as I think a few of you are at this conference, wetlands provide an outstanding place to do education and research. So again, you can see the interdisciplinarity associated with wetlands. The next slide, please. All right, so the question is, what is this unit that I put together? What does it consist of? You know, if you go in and download it, what are you getting? So the first thing is that I have a PowerPoint presentation that I put together that provides basic principles about wetlands. And again, we'll talk about this in a little bit more detail in a minute or two. And so along with the PowerPoint presentation itself, there's an outline of the presentation, sort of a skeletal outline that students can use to take notes over this. Then we also have a set of questions that relate to the PowerPoint that then will assess the student understanding of whether they learned anything from going through the PowerPoint experience. Next slide, please. So then in terms of other things a unit contains, we have a set of instructions for the instructor in terms of, again, how to make this a successful exercise. And then we also have a couple set of instructions for the students. One relates to the wetland mapping exercise that the students do online. So we go through in a step-by-step manner in terms of how to map wetlands in an area that might be nearby to them, or it might be a state park, or it might be just some other location. And then we also have a set of instructions for how to go about doing the field identification and delineation. Now, I think if any of you are familiar with doing wetland identification, it takes a lot of time to get it right. And so throughout the exercise, there are various caveats that tell students that we're giving you a marketable skill, but we're just giving it to you in a very cursory manner. And that if you're interested in doing this, there are other courses that you can take. So we get students to be just dangerous enough that they can have an idea of what they're looking at. Under item number 3, there are then a set of questions to assess whether students are understanding the unit overall. And then we go into explaining how the unit conforms to 4DEE. Next slide, please. All right, so in terms of what we have in the PowerPoint here, and so what you're seeing on the right is just simply a slide of a wetland upland boundary, seeing various colors of flags there. So in the PowerPoint, what we do is we define what a wetland is. We talk about how wetlands are classified in various ways. Again, we go through the whole function and value of wetlands in terms of why they're important. The function, by the way, when we use function and values, function refers to what wetlands do just simply in nature, whereas values relate mostly what they do for humans. So again, you can see that there's a good interdisciplinarity there. Then we talk about the historical perspective of wetlands. So it's kind of a discussion in which we talk about how people at one time did not value wetlands, and then all of a sudden we got smart on things, and that leads into federal wetland protection, although we also have many states that do wetland protection as well. And then we get into the wetland mapping component and then wetland delineation. So you can see that we're providing both theory about wetlands and then an introduction to how you go about doing the mapping, and then how you go about delineating wetlands in the field. Next slide, please. So the question is, how do you go about getting this unit if you're at all interested? And like I said, there's also a crosswalk between the various components of the unit, and then the way that it relates to 4DEE. And so the primary way is going to be through the EcoEd digital library. It's the digital library, if you're familiar with it, or even if you're not familiar with it, it's a place to contribute your teaching information that you might have, whether it's lesson plans or syllabi or labs. And so the digital library, then, one of the benefits for going to EcoEd is that everything that we have on EcoEd is peer reviewed. So essentially, if you submit something to EcoEd, you're providing or you're getting a peer reviewed publication out of it that's sponsored by ESA. And so I went through the peer review process, and I was recommended for minor revision. And so once I do the minor revisions, I look forward to contributing this unit to EcoEd, so you can get it from there. Or if you really don't want to wait for that, and I see that Teresa has given the URL for EcoEd, but also you can send me a request at kenneth.klimo@wilkes.edu. So on that basis, I think that will finish up our unit here, and we look forward to questions. Thank you very much.
Thank you, Ken. Thank you, Vicki.
Thank you, George.
I
Do
know
we
that
have any questions? We have questions in the Q&A.
We have 1 minute, George.
Well,
right.
Yeah.
I've typed some answers to some of mine, so that that ones in there, so they appear in the answered column. But I'm more than happy to take any other questions, and if folks want to email us for questions too, I'm more than happy to do that too.
Okay, well, I guess on that note, we are going to be transitioning to the next program. And that is the Education Share Fair, which is actually going to be happening like right now. So hopefully you'll find the link on the program and we'll see you there. Thank you, everybody.
Thank you.
Thank you to this team here.
Thank you.
Yes. Okay. It was good. It was good. Okay. I'll just end the
Okay.
meeting for all.